Alright guys, what we're going to do here on this page of the notes is we're going to solve yet another quadratic inequality in one variable, which means they want you to solve and find the solution interval, right? Or the interval that represents your solution values, all the possible values of x that are a solution, all the values of x that satisfy this inequality. We do that by solving the related quadratic equation. So I'm going to have x squared minus 3x plus 2 is equal to 0. I believe I can factor this as a general trinomial. At least I hope so. Let's see. My leading coefficient is a 1. So I need two numbers that multiply to give me a positive 2 and sum to give me a negative 3. I don't think you have to work too hard at this one. It's going to be a negative 2 and a negative 1. Negative 2 times a negative 1 gets me a positive 2, and negative 2 plus a negative 1 gets me a minus 3. Zero product property splits those guys up. X equal to 1 and x equal to 2. Now remember, I said previously, when I say graph, I know it's confusing because I gave you a coordinate plane. Just pretend I didn't give that to you. I should have given you a number line, and I didn't. I apologize. You're just going to draw your own, right? So we're just going to draw our own number line. Here it is. And these represent the numbers I'm going to put on my number line to show my intervals, right? So let's see. 1 will go right there. 2 will go right there. And now all I need to do is just pick some test points that I can use in my inequality to figure out what represents my solution region. Well, less than 1 would be 0 would be a very good choice. Greater than 2, 3 would be a very good choice. And let's see, something between, yeah, we're going to go with 1/2. Okay. All right, let's see what happens. I'm going to start with the easy one. If I plug in a 0, 0, 0, that leaves me with a 2. And it says that 2 is greater than or equal to 0. Well, yeah, 2 is greater than or equal to 0. And so I get a true statement. That's true. It is strictly greater than or equal to, so it's going to be a closed circle and everything going in this direction. What about 3? Well, if I plug in a 3, 3 squared is 9. 3 times a negative 3. 9 minus 9 is 0. 0 plus 2 is 2, and 2 is greater than or equal to 0. So this is a true statement, which means it's going to be a closed circle on 2 because it's greater than or equal to, and everybody going in that direction. Well, I don't even have to test the middle point. There's no way that it... Oh, hang on. Actually, let's find out. Maybe. I could be wrong. We go ahead and plug a 1/2 in there. Let me grab my calculator real quick and just check this out. Let's do... Oh, actually here. So 1/2 squared would be 1/4. So I'm going to have 1/4. Let's see. Minus 3/2. Minus 3/2 plus 2. I get 0.75. 0.75 greater than 0. Yes, 0.75 is greater than 0. So this also is a true statement. And what it looks like is my solution is actually all real numbers. So what has happened here is my parabola is either above the x-axis, opening, no, hang on a second, because I have x-intercepts.